So on the one hand, we might say, yes, whatever theories we have at a given time, even if they're our best established theories, the best we're working with, perhaps there's some successor theory which will have some other features than the current theory we're looking at. So that's one thing that we're being urged to look at by Gerard. And it could be that in whatever the successor theory is, it's business as normal with regard to the status of the observer vis-a-vis the rest of reality, something like a return to classical physics. Well, maybe. But the question is, on what basis do we make that judgment? And it doesn't seem to me that things need be like that. Maybe it would be nice if they were so, but maybe we can actually be more excited by what, if you look at the content of many general claims that we would take to hold given quantum mechanics' predictive success, that in fact a more natural thing to think is that there isn't any more fundamental, microscopically non-vague, complete theory to be had. What do I mean by that? We have the process of looking at the general claims made by quantum mechanics, or looking at the confirmed experimental predictions, formulating a yet more general theoretical scheme in which these can be embedded and explained, and then drawing conclusions about what further kinds of theories could possibly produce the results that we've seen in experiments. These are called no-go theorems and no-go experiments in quantum theory, where you're trying to pin down not features of quantum mechanics itself, but features of what the world itself needs to be like in virtue of the predictions of quantum mechanics being confirmed experimentally. And it seems to me that the output of these theoretical and experimental results is in many ways very naturally explained by saying there isn't a fundamental completion, there isn't a fundamental set of laws at the microscopic level describing everything which behave in much the way that physics traditionally has taken it to do. And what's the problem with that? So I want to ask you, Gerard, why the insistence for this atavistic notion of the underlying physics?
I find that all alternatives are much worse. So I think the best of all possible worlds that I can imagine would be a completely deterministic one. And once you say partly deterministic, then you fail completely. When you say, okay, deterministic, but in Bell's famous Gedanken experiment, Bob and Alice still have the free will to choose their orientations, then I say, wait a minute, now you're violating something, and now you're putting yourself in a difficult position. And if you look very carefully at the mathematics, I claim that Bell didn't have his definition of causality correct. So causality to him means that the future will not affect the past, but the past will affect the future. That sounds reasonable, but it isn't. In our models, yes, but in the world, as soon as you change anything in the present, you must have that preceded by a change in the past. Otherwise, a change couldn't have happened. So the problem that Bell was struggling with was that he didn't want to change the past, but he didn't want to change the decisions that Bob and Alice make to measure something. That is forbidden. And that itself is a very strange thing that makes it very hard for us to make models which show that. So Bell thought, because of his arguments, those models are impossible. And I claim, no, we haven't searched hard enough, but I don't think they're impossible.
So, you're wanting to say that quantum mechanics may have appeared to its discoverers and the generation of science afterwards to involve this sort of randomness, if you like, but you're saying they just need to peel back that layer, and underneath there will be some rules which are deterministic, which
but
are like the rules up here.
You have to actively search for that. If you don't do that, you'll never you never do such a thing. For instance, you get string theories, but string theory is also fundamentally quantum mechanical. So this is why I have my doubts also for string theories.
Well, you're not
that
alone
they're
there.
not, they're not there yet, not by long.